Hi, I'm Anna Losiak. I'm from Poland, and right now I'm serving as a RSS team lead. During the mission, I will be taking care of proper procedures and oh my god. I will be taking care about all the experiments, making sure that they are executed properly and that good science can be produced from them. I'm also a PI of one of the experiments myself.
Hi. Yeah, as you said, my name is Klemens Weisleitner. I'm the PI of the L.I.F.E experiment. I guess we talk a little bit later about more details about the L.I.F.E instrument, which can be seen in the background. I'm a PhD student from Innsbruck in Austria, so from the hometown of OeWF, or part of the OeWF, and I'm looking forward to some questions.
Yes. Yes, I'm Christine. I'm a professor at the university in Graz, at the medical university, and we are very much interested in astrobiology and life abroad. And I'm PI of one of the experiments, which is called Glacier-MASE.
Good evening, everybody. I'm the project manager, so I am an astrophysicist who turned to the dark side of astrobiology a couple of years ago. And I'm the one who's organizing the logistics and the science in the background. So I've been preparing this mission for more than a year now. I'm bringing together like 15 nations at this point, and we're right now at like 80, 90 people right now working on that mission. So I'm trying to keep the bag of fleas together here. That's a very good question. Actually, what we did was we made an announcement of opportunity to the scientific community, inviting research institutions to send us proposals for experiments. And then we would have a selection committee actually making a peer review process to make sure that we have a very high scientific standards, that the quality is given, and that also that the experiments fit together. So we group them in astrobiology experiments, robotic experiments, human factors / engineering experiments. So we have a very colorful mix now of 12 experiments which cover all those topics in a way that they fit together, they are complementary, and they also part of a long-term roadmap, because the Austrian Space Forum is just like the facilitator, the catalyst for other organizations to put their scientific research on top and make sure that we have a coherent research program over many years. So that was quite a process. Took us like 3 months or so to go through this, and at the end of last year we had them, and it was like, Christmas time when you announce that, well, you have been selected, and they I think the groups are very happy that they were selected, and since then we are intensifying the work together now.
Well, we as a team, we are taking care that all scientific proposals have been prepared properly, meaning that they have we can see that all of the PIs did their homework, meaning they read the literature, they know what they are going to study exactly, what is their hypothesis, and they have a clear plan for how they are going to solve the whatever mystery of they are interested in. So that was the most interesting for us, and we as RSS team were trying not to focus on too much on other aspects that were left to our team mates from other teams. So yes. Well, remote science support has a few different roles to take care of during the mission and before the mission. So before the mission, we are firstly assuring that the main focus of the mission is scientific sound, so that we will not be, for example, studying some analog sites at the beach, let's say, or some other location that is not very applicable, at least for the current Mars and Mars research. So from that point of view, the site at the rock glacier is very applicable because there are a lot of rock glaciers on Mars. At least we think they are there. Second of all, before the mission, we make sure that analog astronauts and other team members are properly taught about Mars and about different aspects of the mission from the scientific point of view. We also prepare some maps and other kind of scientific infrastructure that helps other teams like flight planning to properly perform their tasks. During the mission itself, we are kind of a local science team that is firstly analyzing some of the data like on the daily basis. For example, this what we are going to be doing during the for the radar experiment. We are going to be receiving some data and then analyzing them the day after. For other experiments that have some external PIs, we will be making sure that the experiments are run as PI wants it to be run. So, for example, usually we will be in constant contact with PIs, so that if there is any questions, something is not it's not right because, for example, the weather is terrible, the PI will be making the decision of if the experiment should be continued or stopped, and so on. Of course, if there are no other issues related, for example, to safety and so on, in this case, Exlead will be deciding.
I'm sorry, Alex, I need to interfere a little bit. It seems that we have an audio problem from your side, and people cannot hear you, but everybody else. Could you just check if your microphone is on, or just switch it off and on again?
And I can hear you very well.
I can hear you well as well.
It's just the outside. Otherwise, I would suggest that I repeat the question when Alex says the question.
I think that.
Sorry, Anja.
Oh, sorry, go on.
What do you think is the hardest job during the mission?
I think making sure that everything runs smoothly, and usually it's not a problem, but from my experience from the previous missions, there are always some small things that are not running properly, and then those small things can escalate to large problems. For us, large problem is that, for example, some part of data that was collected is not usable because someone forgot about a very small and very simple but a key part of the procedure. So making sure that all of important points have been fulfilled, and also making sure that the field team knows how to fix it, and that we communicate well between each other. This is the most important and hardest thing to do.
Sorry, Christine Moissl-Eichinger, what is your experiment about?
Well, to say it in very short words, it's about life detection. We want to find life on the glacier under Mars simulation conditions. We have a background since we are a consortium of several researchers doing research all over Europe at the moment, and we try to understand Mars-like life. So we need to understand microbial life that thrives in Mars analog sites. And we do it by cultivation, we do it by single molecular techniques, and all together we try to get ideas how life on Mars might look at. And so AMADEE is just perfect for us because we can simulate the Mars sampling and also Mars analog sites immediately. So it's all combined for us, very interesting for us.
Would you do research in an extreme environment? Can you define an extreme environment?
Well, extreme is meant from a human point of view. So everything that we feel it's not comfortable for us, it's kind of extreme. So it's quite easy to define. But microbes like this very much, and they can thrive at temperatures above 100 degrees. They can grow at pH lower than 2, and they can do all this stuff. For them, it might not be extreme.
So the question was what my experiment is about. First of all, we have the same aim as Christine. We want to detect life on glaciers. And to do so, we have developed a prototype instrument, which you can see in the background, which is also called L.I.F.E. So we detect life with our L.I.F.E instrument, which stands for laser-induced fluorescence emission. So basically, we use laser pointers like those, like, you know, for presentations. And what we do is we excite certain pigments in organisms on the ice surface, if they are there, and then those pigments exhibit a fluorescence pattern which we can capture with a camera, and then we can analyze this signature, and then we can say this is life, this is not life, and so on. And for studying life on Mars, such missions like AMADEE-15 are perfect for us. We have done a lot of research so far in Arctica and Antarctica, so another extreme study site and analog site. But this mission includes, for the first time, it includes a mission with proper astronauts, and they have to deal with our instruments. So the goal one is to further develop our instrument. We want to detect life, and we want to gain experience with the astronauts, how they can deal with our instrument. And for example, is it difficult for them to take measurements with our instrument? How can we change our setup to make life for them easier on a remote mission?
What do you
Repeat the question?
Mike, the question was, what is the outcome of the experiment? There's several things we expect. First of all, we would like to gain experience with another remote and extreme study site to make the instrument more robust, make it more reliable. We want to gain experience with the astronauts, how they deal with our instrument. And of course, we would like to detect life signatures, which might be the primary goal. And what we would also like to do is to share our results and compare our results with the other experiment groups. That's the main goal, I would say.
We have a question from a user from Team Scarlett. Alex, could you select the question which is you are
yeah.
I just repeat it. Can you please describe all the dangers of dust and sand on Mars? Is the thesis of the book and movie The Martian really plausible, where he uses Mars soil to grow things in and does not wear a filter mask while doing so? So who is willing to answer this question? Who has read the book, by the way?
I read the book and I'm teaching planetology. Maybe that qualifies me. I don't know. No. Seriously, dust and sand is the natural enemy of the astronaut for many reasons. On the one hand, mechanical challenges, it's very abrasive, very sharp-edged, very fine granular. Second problem is electrostatic charging. When it's very dry, you absolutely want to avoid electrostatic discharges on spacesuits, for example. Third thing is the grain composition. And that now depends on where you're landing on Mars. So, for instance, there are regions on Mars which have a lot of hexavalent chrome in the soil, which would be toxic. If you've seen Erin Brockovich, you know what I'm talking about. So these are substances which are not really nice to have. I think the challenge here is the size itself of the dust particles, and that's the reason why, without working with a filter mask inside a station like the Martian does, it's pretty sportive, I would say. The reason is these particles will go down all the way to the lung and might cause something we call fibrosis. So I would guess that within a couple of days there would be some serious respiratory problems associated with just working in unconsolidated, fine granular Martian dust. Anja, would you agree? You also have a planetology background. If this is somewhat complete to the question.
Well, I think that it's a complex question, because I don't think that the contact with dust would immediately cause any problems. So, of course, if you would be breathing in the dust, then after some time it may get bad. But it's actually the composition of this dust is pretty similar to what you can find, for example, during the dusty day in Sahara or something like that. So it's not immediately dangerous, but it can be not very nice. And of course, for the equipment, it's really bad, because it can get attached to some I don't know if I'm not sure if I can see anything. Okay. So
we just had a glitch in the server. It
seems we're back here. Yep.
Yep. We're back here. Okay. So all together back here.
Looks like it, yeah.
Okay, that happens. That's technical stuff. Okay, yeah, so I was asking who can give like a short introduction to some more experiments so people can get an overview of what we actually do in the mission.
Okay, I just repeat the question. Who can give a short overview over the experiment so that people know what we are doing during AMADEE-15?
Should I?
Yeah, go.
Okay. So an overview about the experiment. So we want to find microorganisms, and we want to grow them on the place afterwards, and we want to detect which microbes are there. So we just want to detect the microbial life. What we do is, on the one hand, we try to sample, so that means that the astronaut has to take samples from the environment. And also, maybe based on the L.I.F.E experiment, we have to define which sites are good sites where we expect real life out there. And then the astronaut takes a sample kind of in a sterile way and brings it back so that we can analyze it afterwards with specific instruments. On the other hand, we try to find out immediately on the place whether there's ATP, that is some kind of energy compound that is produced by life. So we try to find it right out in the site. And on the other hand, we really try to cultivate these microbes out there in the field. So we see within a few days whether there are microbes out or not. So it's all based to see whether we can find the life under these critical conditions of a Mars simulation event.
What do you do with your results in the end?
Well, what do we do? Well, for us, it's very important because we are selecting such data from similar environments all over Europe at the moment. So we are also looking at Iceland samples, also looking at samples from deep mines in the UK, for instance, and we will compare all this data and then get a picture of how these microbes behave and how they look like, and to get some kind of a database that we can use for ongoing and future Mars events. So we really need these data to understand how the microbes are and how they look like and how their fossils look like, to really find the life on Mars if it's there.
Okay, do you think there is life on Mars?
I'm completely sure there's life.
Okay, so we have another question from the public.
By the way, your audio is good, Alex, so everybody can hear you now.
Yeah, I don't know. I think there was like a problem in the transmission because I didn't press any button. But yeah, that's technical stuff. So that happens. Okay, the question is, I observed that there is an experiment which will be conducted on human psychology at AMADEE-15 mission. Since the astronauts already know that they are not really on the Martian surface, will you be able to extract authentic psychological test results? So who feels responsible on that?
Maybe
Yes.
In the absence of a psychologist, I can try to keep his head here. The PI is actually a she. It depends what you're looking for. If you're looking into the crew dynamics of where the tension points arise, not all of the environmental conditions need to be fulfilled to see where the problems are coming into existence. Now, the big difference compared to lab studies or isolation studies like the Mars 500 study or so is not only that you in principle you could walk out and be on Earth within like a minute after you decided to leave Mars, but there's one big difference. We were told by Cheryl Bishop, for example, who is one of the best space psychologists I've ever met. She's working at the University of Texas at Galveston, and she's a NASA psychologist. And she said one of the big differences is that you have an actual danger, and it doesn't matter if it's the low air pressure or radiation hazard, or if it's a glacier crevasse which you might stumble in. And if you fall into a glacier crevasse with a spacesuit on, that's a very bad thing. We really want to avoid. And so it's the presence of a real danger over extended periods, and there are already a few days enough to see some of those effects happening, which help us to understand the human psychology. So the bottom line of this question is, yes, it's not 100% authentic, but it's authentic enough to see the patterns which might be relevant to crew efficiency and crew safety.
So yeah, that actually leads me to another question. Let's say the factor of risk. So of course, if you go to Mars, there's no one can save you. Like if something happens, you're stuck. But here, someone would come and help you if something happens. So don't you think that it might change something about the awareness, or also like about feeling of the people?
Yes, that's a big issue in all isolation studies. I think that's a deficiency we cannot compensate for unless we really send people to Mars. However, if we see problems arising because of the potential danger of getting hurt and injured as well, and believe me, working with a spacesuit simulator at 3,000 meters altitude, that is quite a challenge, which is a little bit outside of all of our daily lives, I would say. If anything arises there, we will surely have those challenges also on Mars, plus the distance, of course. Now, of course, the people who will be flying to Mars will have a longer training time, will they have a more carefully team selection process behind them, but we put a lot of effort to make sure that the people who are actually in the flight crew, and especially for the analog astronauts, that they are selected in a similar fashion like you would do it for an actual space mission. Now we had almost 100 applicants for that particular mission. They underwent 637 individual tests before we selected the final 5, which went through the basic training and complemented the existing team of 3 actual current analog astronauts of the Austrian space program. So we put as much work as we could into a realistic setting.
So yeah, what do you think? Let's come to like a more, let's say, philosophical or complex question. What do you think analogies or like analog missions can tell us about the reality on a planet we have never been to?
Maybe somebody else?
I can tell something from the scientific point of view. So from the scientific point of view, to learn something useful about another planet, you do not have to replicate every single variable on this planet. So for example, if you want to study geomorphology, it's enough to replicate only some parts of this environment. You don't have to know everything. You don't have to replicate all variables of this environment. So for example, even though the air pressure is much lower on Mars, some of the geomorphologic processes are very similar. For example, forming of the dunes. The dunes are forming in more or less the same way. Of course, you have to compensate the pressure, slightly different composition of sand and so on, but the general physics of the process is exactly the same. And yes.
What do you think in general is the factor you can do the less experiment and the less like preparation for a real mission to Mars? What can't you research at all? Is there something? Like in beforehand?
There is one thing you cannot simulate, but the answer to this is we don't know what. So for any risk we take by going to Mars, for any scientific question we're trying to address, the more we know about the environment, the more we can be precise on the design of the experiments, for example. So maybe we don't expect so many surprises there for the things we know. However, there are things we haven't thought about, environmental conditions we haven't accounted for, surprises which we just didn't know. And I think this is exactly both a source of risk, but also, and that might sound a little bit philosophical, a part of the magic of exploration. We don't know what awaits us there, but for me, that's a very reason to go there and have a look. And if we look back into past exploration expeditions in the past hundreds of years, that on one hand led to surprises, new sources of resources, new worlds to be discovered, new continents to be discovered, and I think it will be no different from Mars. And that's, beside the intrinsic scientific questions, just one more reason why we must go.
What do you do in the end with all the all the research data you find out during the mission? What are you going to do with it? Do you only use it for the Mars mission? You try to plan, or can you also use it for Earth?
Absolutely. First of all, there is a science data archive where we invite the scientific community to take advantage of all the research data we took. There will be publications, of course, but we, for this time, especially for geological experiments, and Anja can talk about this in much more detail than I can, for example, looking into the composition or the properties of the glacier is something where the Austrian glaciologists who are working on the Austrian glacier inventory are very interested. So this is one example where we do a space experiment, but we benefit even science here on Earth.
Yeah, something I'm really interested in, like we have a Hangout now, so we share our thoughts and our research to the public. Why do you think it's important to do that? Whoever wants to answer.
Well, it is a general thing for science that we have to share our data and to let all the people know what we find out. And I think it's fascinating, and in particular, space travel is tremendously fascinating for many people. And this is where we can bring also the young people to contact to real science. And I think that's a fantastic platform to do it.
Yeah. So what did inspire you to do actually all these kind of experiment? Maybe the people who handed in some experiment. How did you got this idea to do that?
Well, in our case, it fitted perfectly well to that what we are already doing, and it's just one additional task more, and it's more realistic than that what we are doing at this moment. So for us, it was perfect environment, and we also seek, of course, the contact to other scientists, and we really want to network with many other people, and also to, of course, well, widen our interest.
Okay, Klemens, what about you? How did you got this idea? How did you invent all the technical stuff? How did your thoughts go?
So actually, the prototype was built before I started with the experiments. But basically, I got this instrument and I was told deal with it and develop it and further develop it. And I got really into it, and I spent a lot of time thinking about this device. How can I improve it? How can we make it possible to detect life under various conditions, ambient conditions, and I think this was a really important job. At least for me, it was an important job. And as you mentioned before, how to get where you get your motivation and your enthusiasm. I want to also tell other people what we are doing. And for instance, we have a really, really nice project which involves children from school classes, and we invite them to our labs, and do basic research with them. And we also take them on the mountains, on high altitude sites, and we do some snow and ice science with them. And when they come back from a study site, you see this glow in their eyes, and this is really motivating. They're really fascinated, and you can almost hear them thinking loudly that they really want to go in science and start doing the same things, and that's really great motivation.
That's a good motivation to spread the idea. So we have another question from the public. Why exactly you work on this project? Is there anyone among you who really wants to undertake a Mars mission? I'm also interested in that. So who wants to go to Mars?
But I would like to come back, not one-way mission.
That's the point.
So yeah, who would like to?
Yep.
Oh yeah, could you imagine going there?
Yeah, it would actually be really, really interesting, especially if you manage to go to the far north, to the Martian Northern Polar Cap. So Mars, similarly to Earth, has large ice caps on both poles. The northern one is larger, and I think that it's one of the most geologically active place on Mars right now. Also, it's a very nice place where a lot of organisms could potentially live. So if I would be able to go to Mars, I would really like to go there and then check what exactly is going on there from the geological point of view, from the geochemical point of view, how minerals are weathering, what is produced and why, and also talk to a friend, another actual astronaut, that would be biologist, that would check out if maybe there are also some microorganisms growing on the ice of Mars.
Thank you. Klemens, what about you? Would you go to Mars?
That's a tough question. I think I would like to go if I come back again. And maybe it's not the same, but I've been 2 times in Antarctica, and I know it's not Mars, but for me it's already far away, and living in harsh conditions for 6 weeks in a tent, and you get aware of your situation and about the risks you take. I mean, even there, it's risky to be there, and if anything happens, you have a big problem. But it's a feeling. I cannot really explain why, but it's a magical place. So there's a feeling that I always want to go there again and again and again. And I think it could be the same with Mars. I mean, it's a fascinating place, and yeah.
Just
sure.
one ride for a person. Come on.
So yeah, okay. I think, okay, we have no further questions from the public. So we got a brief introduction in the scientific part of the AMADEE-15 mission. Is there anything you want to add to what you've said, or something you really want to share to the public at this last moment?
Well, there will be a lot of interesting science produced afterwards, well, during the mission and then produced afterwards. So if you are interested, just keep an eye on us and be amazed, hopefully.
Yeah. I think for closing in what Anja just said, I think we need the public, and it's not that it's us going to Mars and the public is just watching or so. I think they should be an integral part, because we are not just going there for the flag and footprints. We're not just going there for science. We're not just going there for demonstrating our national pride or what we can do as Europe or so, or as Americans whatsoever. We are going there for all mankind, and I think our time will be remembered as the time when we broke for new shores, as the time, the generations when we left the cosmic shores. And so I think we have an obligation by standing on the shoulders of giants, of people who made those journeys possible, and we are more to be considered like the shipbuilders in the analog research community, so that we are the enablers. But this can only be done together with the public, because in the end, and that's one of the reasons why we are sending humans as well, is that's only we want to see boot prints and not rover prints, not only rover prints in the Martian sand, but we need humans to tell the story, what it's like to stand on the surface, feel the breeze of the winds, and maybe even the taste of the Martian dust. So I think this is something which is so intrinsic to the human condition, that this is part of a grand adventure we as humankind share. And that's the reason why we need to include everybody.
So thank you. Yeah, so that goes to everybody. You can be a part of our mission. So in the first, also, if you follow our sites and share your ideas to us. So yeah, thank you all for participating in this hangout, and I wish everyone a lot of luck and success with the experiment, and see you in the next month for the next hangout. Goodbye.
Bye bye.
Bye.
Goodbye.
Goodbye. Good evening out there.
Bye bye.